So we're going to start with circular motion, and let's take for instance any given particle, and let's suppose that the particle is moving in a circular trajectory such that it has its center in the center of the circular trajectory, and the circular trajectory has a radius r. Now it could happen that the particle is moving at a constant speed, which means there is no variation in the amount of distance per unit time. But if we analyze, for instance, the velocity of this particle, the velocity is going to be a tangential vector to the circular trajectory. And we could state this is the initial velocity, this is a vector, and this is at time, at initial time, for instance. Now, seconds later, the particle can be moving with the same velocity at another time, right? At time t, for instance. And probably the magnitude is not changing, but since since the velocity is changing its direction, then the vector itself is changing, which means velocity is changing. And that changing velocity has to be provided by an acceleration. The acceleration that changes the direction of the velocity in this case is called centripetal acceleration. The centripetal acceleration or radial acceleration is always going into the direction into the circular motion. That is, it's going towards the center. That's the reason why it's called centripetal. Or it is parallel to the radius, that is called what is called the radial acceleration. And this centripetal or radial acceleration is given as the square of the velocity over the radius. Of course, it could happen that there is a change in the magnitude of the velocity, and that is given by the tangential acceleration. So the tangential acceleration is only to change the speed or the magnitude of the velocity in the circular motion. At the very end, this particle has two components of the acceleration. The first one is the radial acceleration, which goes towards the inside of the circular motion. And its only objective is to change change direction of the velocity. There is another acceleration, which is the tangential acceleration. This tangential acceleration is the change of the velocity due to time, and it only changes the magnitude, and it goes in the tangential line. And of course, if we add this up, we end up with the total acceleration of the particle. And since both radial and tangential acceleration are always perpendicular, if we add these two vectors, the acceleration is given by the sum of these two vectors, which is given by Pythagoras. And the direction of this is given from the radius, which is given by the inverse tangent of the opposite side, which is tangential over the adjacent side. And when working with these kind of situations, we can state that there are two important terms. The first one is called a period. It is denoted by the letter t, and this is a time, for instance, and it's the time for the particle to complete a revolution, or for instance a turn. And of course, one revolution is given by 2p radians, which is for instance 360 degrees. So it's a complete turn, the period. It's the time for this particle to complete this revolution. Now the inverse of the period is called the frequency. This is denoted by the letter f, so frequency is 1 over period, which means if the period is the time for the particle to complete a revolution, then the frequency is the amount of revolutions that it gives per unit time. And of course, the period, since this is a time, is given in seconds, while the frequency is given in 1/2, which is, for instance, called hertz.